The James Webb Space Telescope has delivered what may be one of the most astonishing discoveries in the history of astronomy. This advanced instrument has peered deeper into the cosmos than ever before, revealing findings that directly challenge everything we thought we knew about the origins of the universe. Astronomers have been stunned by the discovery of galaxies existing during a period known as the Dark Ages, a time before galaxies were even supposed to exist. This revelation has shaken the foundations of cosmology, raising profound questions about the accuracy of our current models and the nature of the cosmic timeline. Initially, scientists were working under the assumption that the universe was relatively well understood in its early stages. They believed that during the Dark Ages, shortly after the Big Bang, the first stars and galaxies had not yet formed. But what Webb has uncovered tells a different story. Now the astronomical community is asking itself an important question: is there something wrong with the data, or have we fundamentally misunderstood how galaxies and stars came into existence? These questions have now become central to discussions about the formation of the cosmos, as new evidence suggests we may be missing something critical in our understanding. The discovery of massive, bright galaxies in the early universe contradicts the standard cosmological model. For years, astronomers had been waiting for a breakthrough, something that could provide definitive evidence of the existence of massive galaxies in the more distant universe. This would have confirmed what many had feared, that our understanding of cosmology might be incomplete. Surprisingly, that moment has now arrived. The James Webb Space Telescope has managed to uncover a galaxy so massive and so bright that it has sent shockwaves through the field of astronomy. Even more astonishingly, this galaxy appears to be older than the Big Bang itself. This monumental discovery has forced scientists to confront a seemingly unthinkable possibility. If galaxies like the one recently observed by Webb truly existed before the Big Bang, it implies that the universe may not have begun 14 billion years ago as previously thought. This has led to widespread concern among astronomers and cosmologists, who are now re-examining the fundamental assumptions that underpin our understanding of the universe's origins. As the James Webb Telescope continues its deep dive into the farthest reaches of the cosmos, more and more massive and bright galaxies are being discovered, many of which appear to exist in the earliest periods of the universe's history. This is raising a host of new questions about the reliability of the cosmological model and the very nature of spacetime itself. So what exactly did the James Webb Telescope observe, and why are scientists across the world now saying that this strange ancient galaxy could change everything we thought we knew about the universe? Recently, the James Webb Space Telescope set a new record for detecting the most distant known galaxy. This galaxy, known as Jade's GZ4, has been heralded as one of the most significant discoveries in recent times. What makes this galaxy particularly remarkable is that it breaks the record set by another distant galaxy discovered by Webb just a year earlier, named Jade's GZ3. These two galaxies, which date back to just a few 100 million years after the birth of the universe, have left scientists questioning the accuracy of existing cosmological timelines. The name JADE stands for the JWST Advanced Extragalactic Survey, an ambitious program designed to use the James Webb Space Telescope to explore the first few 100 million years of the cosmos. Jade's GZ4, the more recently discovered galaxy, is a redshift 14 galaxy, which refers to a term used by astronomers to describe the distance and age of faraway objects in space. Redshift is essentially a way to measure how far light from an object has traveled to reach us, with higher redshift values indicating greater distances and earlier points in the universe's history. Through meticulous spectroscopic observations, scientists have confirmed that Jade's GZ4 existed when the universe was just 290 million years old. To put that in perspective, the current age of the universe is estimated to be about 13.8 billion years. This means that when we observe Jade's GZ4, we are essentially looking back in time to an era when the cosmos was only 2% of its present age. What's even more extraordinary is that Jade's GZ4 is not just distant, it's incredibly bright and large. In fact, it is 5 times brighter than Jade's GZ13, which previously held the record for the most distant galaxy ever observed. This level of brightness is highly unusual for a galaxy from such an early period of the universe's history, raising serious questions about how galaxies like this could have formed so soon after the Big Bang. Researchers are particularly fascinated by the sheer size of Jade's GZ4. According to measurements taken by the Webb telescope, this galaxy is more than 1,600 light-years across. Many of the brightest galaxies generate their light through the process of gas falling into a supermassive black hole, but that does not appear to be the case here. Instead, scientists believe that the light from JADE's GZ4 is being produced by young stars. These stars are burning so brightly that they are visible across billions of light-years of space. Astronomers including Stefano Carniani and Kevin Heinlein from the University of Arizona have noted that the amount of starlight produced by this galaxy suggests it is several hundreds of millions of times the mass of the Sun. This raises an intriguing question: how could nature form such a massive, bright, and large galaxy in less than 300 million years? This is a mystery that has left many cosmologists scratching their heads, as current models of galaxy formation simply cannot account for the existence of such a massive object so early in the history of the universe. What's even more intriguing is that the James Webb Telescope could have detected JADE's GZ4 even if its light were 10 times fainter than what was observed. This opens up the exciting possibility that the telescope may soon reveal even older objects in the distant universe, perhaps even dating as far back as the first 200 million years of cosmic history. Another fascinating aspect of JADE's GZ4 is the discovery of oxygen within the galaxy. The presence of this element indicates that JADE's GZ4 is already quite mature despite its incredibly young age. For oxygen to be present, there must have already been multiple generations of very massive stars that lived and died producing oxygen through their supernovae. These stars would have had to burn through their life cycles, quickly releasing oxygen into the galaxy in the process. This raises another important question: how did this all happen in just 290 million years? The formation of oxygen and the presence of mature stars in such a short period is something that current models of stellar evolution cannot easily explain. This has sparked a major debate among cosmologists and has led to calls for a fundamental re-evaluation of how galaxies formed in the early universe. These observations imply that galaxies like JADE's GZ4 must have formed much more rapidly than we previously thought possible. This rapid formation poses a significant challenge to our understanding of galaxy evolution and the timeline of the early universe. If galaxies this massive and luminous existed only 300 million years after the Big Bang, it suggests that either the universe is much older than we think or our models of its early evolution are fundamentally flawed. At this moment, scientists are still unsure of how galaxies like JADE's GZ4 could have formed so quickly. Some have even begun to wonder if these galaxies existed before the Big Bang itself. This radical idea, while not yet proven, has gained traction among some members of the astronomical community who are looking for alternative explanations for the rapid formation of early galaxies. Adding to the growing list of cosmic puzzles, earlier observations from Webb had already surprised scientists by revealing that the expansion rate of the universe is not uniform. This means that the universe is not expanding at the same rate in all directions, a finding that contradicts previous models. It has also been shown that the distribution of matter in the universe is not isotropic, meaning that the cosmos does not look the same in every direction. These discoveries have already shattered several key pillars of cosmological theory, and now the presence of these distant bright galaxies has only made the mystery more complex. While several hypotheses have been proposed to explain these strange phenomena, there is currently no definitive model that can fully account for what Webb has revealed. One potential explanation for these findings is the idea of the universe prior to ours. This concept, known as conformal cyclic cosmology, was proposed by Nobel laureate Roger Penrose. According to this theory, the Big Bang was not the beginning of time, but rather the start of a new cycle in an eternal sequence of universes. Each Big Bang is essentially the result of the collapse of a previous universe, meaning that our universe is just one in an infinite chain of cosmic events. Another equally intriguing idea is the possibility of multiple universes. Some scientists have speculated that the early universe we observe is not alone, but is part of a multiverse, a concept that suggests there are other universes beyond our own. These universes may have different physical laws or have evolved in unique ways, potentially accounting for the rapid formation of galaxies like JADE's GZ4. A recent study published in the Journal of Cosmology and Astroparticle Physics even suggests that the rapid expansion of our universe could be explained by a collision or merger with another universe. The authors of this study argue that the expansion rate of the universe can be best explained if our universe merged with a larger, more massive universe during its early stages. The result would have been the rapid inflation of spacetime and the formation of massive galaxies like JADE's GZ4 far earlier than previously thought possible. Lee author Jan Amber, a physicist at the University of Copenhagen, states that the theory of baby universes merging with our own could provide an explanation for both the rapid expansion and the different rates of cosmic growth detected by Webb. While these ideas are certainly fascinating, they remain largely speculative. The James Webb Space Telescope continues to provide data that challenges our understanding of the cosmos, forcing us to reconsider long-held beliefs about the origins and evolution of the universe. Every new discovery it makes raises more questions than answers, and it's becoming increasingly clear that we are only scratching the surface of the vast mysteries that remain. In the end, we are left wondering, why is the universe so complex? Are we missing a fundamental piece of the puzzle, or is the cosmos truly more mysterious than we ever imagined? The James Webb Telescope has only just begun its journey into the farthest corners of space, and there's no doubt that many more surprises await. Subscribe to our channel Oscar Discoveries for more insights and updates on these remarkable revelations, and stay tuned as we continue to explore the incredible discoveries that are reshaping our understanding of the universe.